Welcome to the Explainer. You know those web apps you use every single day? Your social media, your shopping sites? We're about to peel back all the layers. We're going to follow the entire journey, from the moment you click your mouse all the way down into the code itself.
So let's really get into it. You click a button and boom, something happens. But that boom is actually a super fast, really complex conversation happening between a bunch of different systems. Today we're going to take apart that magic and see how it works.
So here's the plan. We'll start with the big picture, then break down the three main parts: what you see, the engine behind it, and the messenger that connects them. Then we'll follow a single click all the way through the system. And to wrap up, we'll talk about why this whole setup is so important for the future of the web.
To really get a handle on this, the key is to stop thinking of a web app as just one thing. It's not. It's a system, a team of different parts all communicating with each other, and each one has a very specific job to do. This restaurant analogy, it's pretty much perfect. The front end is the dining room. That's your experience, what you see. The back end is the kitchen. It's hidden from view, doing all the hard work. And the API, well, that's your waiter, the crucial messenger running back and forth between the two.
All right, let's kick things off with that first layer, the front end. This is literally everything you see and interact with inside your browser window. The buttons, the layout, the images, it's the whole user interface.
So the foundation for any good, modern front end is something called semantic HTML. In the old days, developers might have just used generic boxes for everything, but now they use tags that actually describe their own purpose. It makes the code way easier to read, better for search engines, and a lot more accessible.
Now, this is where modern web development gets really smart. Instead of building every single page from the ground up, developers create small, self-contained, and reusable little bits of the interface. We call them components. You can think of them like Lego bricks for building a website.
And here's what the code for one of those little components might look like, using a super popular framework called React. Now, hey, don't get bogged down trying to read every line. What I really want you to notice is that little arrow symbol. It seems small, but it represents a huge shift in how modern code is written.
Right, so that little symbol, that's what we call an arrow function. It's just a much cleaner, much more compact way to write the functions that handle things like, say, a user clicking a button. It might look like a tiny detail, but this kind of modern, readable code makes building these huge, complex apps so much more manageable.
Okay, we've seen the dining room. Now it's time to push through those swinging doors and head into the kitchen. We're going behind the curtain to the back end, the powerful unseen engine that makes everything run.
This is the server side of the app, right? It lives on some powerful computer in a data center somewhere, just waiting for requests. It's in charge of, well, everything, from figuring out what information to show you to making sure you're actually allowed to see it.
So the back end is a serious multitasker. It handles your login. It talks to the database to grab or save data, and it enforces all the business rules. What's really cool is that a lot of modern backends use something called Node.js, which lets developers use the same language, JavaScript, for both the front end and the back end. Pretty efficient, right? So you've got the front end and the back end, two separate worlds. How on earth do they communicate? That's where our waiter comes in, that crucial messenger we call the API.
Most of the time, they use something called a REST API. You can think of it like a very strict set of grammar rules for their conversation. And one of the most important rules is that it's stateless. That means the server has no memory from one request to the next. Every single message from the front end has to include all the info the back end needs to do its job. And this conversation has its own set of verbs, or methods. Get is for, well, getting data, like loading a product page. Post is for creating something new, like posting a comment. Put is for updating something that's already there. And delete? I think you can probably guess what that one does. All right, we've met all the players. The front end, the back end, the API. Now for the fun part. Let's put it all together and trace what happens when you do something simple, like adding an item to your shopping cart. And just look at this chain of events. It's like a perfectly choreographed dance that happens in a fraction of a second. You click the button. The front end sends that post request to the API. The back end gets it, tells the database to add the item, then sends a success message back through the API. The front end catches that message and, finally, updates the screen, all from one click. You know, this whole system of separating things out, it's not just about being tidy. It is absolutely fundamental to building applications that are strong enough to grow and change over time. You see, the old way of building things was what we call monolithic, one gigantic, tangled mess of code.
The modern way is to use microservices, where you break a big app down into a bunch of smaller, independent services that all talk to each other using APIs. Now, it has its own challenges for sure, but the flexibility you get is a total game changer. And this whole idea, it really taps into a classic, super wise bit of programming philosophy from the early days of Unix. Make each program do one thing, but do that one thing really, really well.
And that right there is the whole point. This modularity means a team can update the payment system without ever touching the user login system. If one little part has a problem, it doesn't crash the whole app. It creates systems that are just so much more resilient and easier to manage as they grow.
Which, of course, leaves us with a really mind-bending question for the future. As we keep breaking our apps into smaller and smaller pieces, all connected by faster and faster networks, what does the word application even mean anymore? It's a look into the future of the web, and it's all built on the layered anatomy we've explored today.